Hi everyone, this is me Abhinav. I am IIT Madras online degree program data science student, and today, as we know, tomorrow is our quiz too. So I am today revising the DBMS part, and this will be the short just the overview of the DBMS part, so that it kind of it is kind of short note type. So I will just give the overview of all the topics related. So this video I will cover until week 1 to week 4 content. So let's start. And I have prepared some PDF, so you can also go through it on a scribed. This is not my handwritten note, but this is helpful to us. So in the first, what is database? As we all know, database is the collection of data. Mm, why do we need database? To providing a way to store and retrieve the database information that is efficient. So why we need data uh, database? So that when the user give some specific information, so that we can easily interact with the data and can easily it retrieve the data from the user. And what so there are two type of basically we are having two type of database. Earlier we used to store in the file system, and now the technology evolved, we stored in kind of like a DBMS system. So file system, was a disadvantage in the file system, because for every data we need to create some new file. If you need to store student data, then we will create some student file. Then we will store the information related to the student specific. So this system fails because there is some kind of load on the server. We will search through the multiple student file. So it kind of so that it is kind of like retrieving data is tough from this system. So we come through the solution. Later on we just evolve, and later on we come through the solution of DBMS, so that we can easily interact with the data, and we will write the query, and it will be retrieve the data in the efficient manner. So this is the why the disadvantage of the file system. And so there is also inconsistency problem. Data may be inconsistent, different. So there is not kind of consistent data we can store here. And there are multiple duplicate file also created, so that for the duplicate user we can have the multiple file. So this is kind of some inconsistency. We are tackling with some inconsistency problem here. And there is data isolations integrity problem. So integrity problem means we are some need to apply some constraint related to the data. And what is the atomicity problem means, it is like when suppose there is a bank system, we are working on the bank system. So uh, the transaction doesn't process, the means like the transaction failures. In atomicity problem, we tackle about the transaction failure process, means one transaction doesn't affect the another transactions. In some kind of problem, like when we do transaction of 5,000 amount to one user to another user. So when we send the 5,000 amount, which is in the data forms only, 5,000 amount to one user to another user data. If 5,000 amount doesn't transfer to the bank 2, but it is debited from bank 1 account. So this problem, that bank 2 will claim that the amount doesn't received by me. So this kind of system called transaction failure. So that if the transaction doesn't complete the process, then we can roll back to the bank one database, and then we will credit somehow the account easily. So this is a kind of atomicity problem. So the next thing is con- wait for the ad. So now next, what is instances and schema? Instances are the collection of information. Like if the user like I am the user creating the student table, a student table, and in the student table I am keeping the records of some other student. So at the particular instance, at the particular instant, what the data are stored in the database is known as instances. And a schema says that overall design of the database, overall design means like how the tables appear in the database is known as a schema. Basically it's just the table, and instances it is like the data are stored at the particular moment. So moving next, what are d database language? There are two type of database language, which is database data definition language and data manipulation language. So what is data definition language? This data definition language used to modify the schema. So sort of there are sort of commands like it is a schema specific. And what is a schema? A schema means like it is I just mentioned, it is the tabular form or a whole the database design. So there is command like create tables, these alter tables. This is the DDL language. And what is DML language? When we sort of used to modify in an instances, insert, update, and delete suches. So when we write the query like select and insert command, select command and insert command, this is data manipulation language. It is kind of altering the instances, or we can say modifying the instances. So types of DML, data manipulation language. There is two types of manipulation language, which is procedural and non-procedural. Procedural require a specific that what the what the user need, what the data user needed, and how the data, we just query this data I need, and by via this method we just write the procedure how do I extract, how do I retrieve the data from the database. And in non-procedural we just write the query select dash from select a star from this table. We didn't care about how the data are extracted, like as an example like SQL. So here I will just move to the view part of view of data. There are three type of view of data, which is logical, physical, and view table, view level. So view level is the topmost level, where view is the topmost level of the view of data, which customer can only see the user data. So moving let's leave this part. I will just explain how, just the overview, how does it the view of data works. View label hides the unwanted information. Like when we retrieving data from the database, like I need the some user specific information, Rahul information. So it will not share the particular things, like it will not share Rahul's password, Rahul's some sensitive information. It will doesn't share the some sort of sensitive information or the password thing. So it hides the unwanted data, and it retrieve the data what user need. Now coming to the middle layer, which is logical level. In this, not concerned about the how data, this level doesn't concern about how the data are stored on the disk. It just query the data. So it just thinks like how do I extract the data from the database. what the data are, how the data are stored on the disk, it doesn't concern about this part. So at the last level is the physical level. This part cares about how the data are stored on the hard disks. So this is also completed. Now moving to the key feature, like it is the key feature of view of data. Security control, for at first is the security control, that what the user need data, that was part it will only retrieve. Simplicity means like it is joining the multiple table through the via the relationship established among the tables, like a student a student enroll for these courses. So enroll is the relationship, so joining the two entity of the data. Now coming to the database architecture system, how the database are architect. Database divided into modules that manages everything from the user request. So how the database architecture work? There are physical storage system, which is query processor and a storage manager. So what does the query processor do? Query processor is the brain of the database, and the storage manager is like muscles to the database. So what is query processor? Query processor is what it translate the SQL commands, which is high level language, into the lower level language to the storage manager. It just translate the high level languages to the lower level instructions to the storage manager, so that a storage manager can easily execute all those SQL commands, so that user can easily retrieve the data from the storage manager part. So this query processor part consists of some of the features, like DDL interpreter. There are some steps to the query processor. So what is the steps? There is DDL interpreter, DML compiler, query optimizer, and the query processor. So how what is DDL interpreter? DDL interpreter process DDL. We have just studied that what is DDL. DDL is a data definition language, sort of commands like create tables, alter table. These are the DDL commands. So what is does it it process the DDL commands. It just DDL interpret just process the DDL commands. And what does DML compiler do? Translate the DML command. Translate the DML command, which is hide, which is mostly like SQL command, like select and insert into the low level, and comes under the evaluation part. And what does the query optimizer do? That analyzes the DDML compiler, and they analyze the compiler, and it speaks the absolute. So after analyzing the SQL command, after analyzing the SQL command, it picks the absolute fastest ways to retrieve the user a specific information. So it just analyze the command, and since the faster way to execute the command. And and the last part, DDL evolution engine, what is does after the it does the executing process, that which is done by the query optimizer, um, low level language and interaction generated by the optimizer. So it just executed the low level interaction, which is I just messed up this part. I will end up with the good explanation at the end. So just for the is uh, I will recap this whole part because I messed up, I know. So we are on the track of database system architecture. Database system architecture divided into the modules that manages everything from user request to physical storage. So there is a two part of database architecture. One is first one is query processor, and second one is a storage manager. What does the query processor do? Query processor is the brain of the whole architecture system. It translates the SQL high level language into the lower level languages to the storage manager, so that storage manager can easily read the whole the query command, and can easily retry, and you can easily give the data to the user. So there is the some kind of steps behind the query processor. So the first step is data interpreter. Data DDL interpreter. What does DDL interpreter do? DDL interpreter do the process the create tables like command DDL commands, and then the DML compiler responsible for translate the whole DL command like select and insert into the lower level instruction, and comes under the evaluation part. And what does the query optimizer do? It analyze the compiler analyze the compiler plan, and picks the absolute the fastest way to retrieve the data, so that retrieve the data, and most efficient way to execute the query. So it just analyze the compiler and sends the fastest way, so that can easily execute the query. And at last, query evolution engine execute the lower level language, which is lower level language instruction, and generate which is lower level languages, which is generated by the query optimizer. So it just execute the whole mm, whole process. Last part, query evolution engine is just execute the whole process. So, and coming to the next part, the storage manager. A storage manager provide the interface between it just provide the interface between the because a storage manager reads the lower level languages, which is converted by the query processor, which is a storage manager. It provides the interface between the low level data stored on the disk and high level application program and query sent to the system. So what a storage manager do? Storage manager reads the low level language. And who is responsible to convert the low language, which is query processor convert the high level language to the low level languages, and the storage manager reads the lower level languages. So it acts as an interface between the lower level data stored on the disk and high level application program, and the query to the system. Like it just read the low level data, and and just give the information to the user which the user needed. So there is sort of some authentication, because manage authentication, transition manager, and file manager, and the buffer manager. So what is authentication? As per user request, it will send the data, and it will not share the some kind of sensitive information. It is acts like the checkpoint. If the like when we query something, select a start from the that student table, so it will not send the password to the user. So it just authenticate, and it's the check constraint. We just give the on the table, when we design the table, we just give the check constraint at the some instances, so that user can retrieve to the useful data only, not the unwanted data. So authentication is something like this. And transaction manager means till the whole transaction completed, till so it acts as a data is consistent or not, is the transaction completed or not. So it will manage the whole transaction process. And what does file manager do? File manager just keeps the information to the disk permanently. And what does buffer manager do? Buffer manager is the temporarily it fetches the data from the cache memory. And what is cache memory? Cache memory, we can think like this: it is a temporary storage system. uh, Temporary storage system. So how the cache memory work? So when we like something when we give some information to the system, then the frequent the frequent the frequent data, it just keep the frequent data into the cache memory, so that when we need the data, it will just go to the cache memory and retrieve the information related to particular data. So this this how the buffer memory works, so that it will not directly go to the our sdt part or some kind of permanently stored part. Because it is the when we go to the sdt or some permanent storage system, it is it is like tougher to retrieve, or it is like the slow process to retrieve data from the permanent storage, rather retrieving data from the cache memory. So that we can easily go to the so that system easily check the cache memory, is this data available on the cache memory or not. If the data are available in the cache memory, so within a second it will just give the information related to a user a specific. So how this buffer manager works. Now moving ahead with the data from the disk in the faster. Now moving to the disk storage. So what is disk storage? This is the permanently. Now we just move ahead from from we just move ahead from the database architecture to the we just move the data storage. We just moved first we studied about the query processor, then we studied about the storage manager, and now we are moving ahead with the disk storage, the vault. Actually in actual information, like when we it's something like that, like we created a table. Okay, so we created a table. Now we just stored on the hard drive. We just stored on the hard drive. When the some kind of when the transaction is incompleted or system crash, the whole system are permanently saved on the hard drive. So it is the permanent storage system type. So this also have some data dictionary. What is data dictionary? A structured information about the it is the structured information about the database itself. So what data dictionary do? It gives the structured information, like table name, which is a student, and some attributes related to the table name, like column type. We just give the permission, and we give some constraint, and we just give information about the primary keys. So this is the data dictionary. Just give the structural information of the data to the hard drive. And we also mention some indices. What is indices? Indices is just kind of, we can think like this: it is the index, or the kind of it is a specialized data structure, like B tree, AVL tree. We are not using AVL tree in the database management system. We use a B tree. We use B plus tree. So how the data are stored on the disks. We use some B tree like a structure, B plus tree like a structure, so that it is easy to retrieve the information from the disk part within or maintain some time efficiency also, so that user can in one go can retrieve the data from the database system part through the indexing. We have some has has code also, has code also. Now, type of interacting with architecture. So now whole the system architected, whole the DBMS architecture are maintained. Now, how the user interact with the whole architecture system. So we have some naive user, application programmer, sophisticated user, and a specialized user, and that database architecture manager, DBS. So who is the naive user? Naive user interact through pre-built application like ATM machine. So we have some ATM machines. We just need to insert the card into the ATM machine, and the whole the ATM machine DBMS system just analyze the whole the da- whole the data related to my uh, ATM card. So it just read the whole the data of my it just read the whole data, just simple like this. And then mm, if we if we withdrawing if we are withdrawing 500 amount, so it will check my if it will first it will check my the data, is this amount is available or not, some check constant there, is this amount available or not. If this available, then then just give the cash, or retrieve the cash from the ATM machine, 500 amount, and it will just do the some sort of operations, like if the data, like kind of manage my amount, and then just retrieve the information. So this is the naive user. And what is the application program? Application program, who is the application programmer? Who access DB by writing program? Like we code to access, access the data, or retrieve the data. We use some DML commands like select or insert. And who is the sophisticated user? Who designed the database tool, or we write some raw SQL query into database console and to analyze the data. And who is the DA, database administrator, who manages the whole database system, control entire structure. It controls from the scratch to the advanced level. So this part is also completed. And we have some we have some two-tier architecture and three-tier architecture. What is two-tier architecture? We have some client and the server. We just client give the information to the DB system through the network. And three in the tier architecture, there is three level of certain kind of server. You first is the user, then application client, kind of Amazon. We just click on Amazon, so application client is the Amazon. And to the application client, we send the request to the application server. We need to purchase some kind of headphones, then the request are sent to the application server. Then it will check to the database system, is this headphone is available in the system or not. If the headphone is available, then it will give the response to the application server. Then it will send the information to the application client, yeah, this headphone is available, if you like to order, then place order. So tier architecture work like this. What are data models? There are two type of data models. And at first instances, when we think of data models, there are ER model and the relation model. In the ER model, we do we just design the whole database system through the diagram. And later on design are created. Then we just write the query part through to execute our plan. So this The definition is a conceptual tools for describing data relationship, data semantics. What semantic means? The meaning of data, the actual crux of the data. So for why we meaning, we can say we are like managing the employee and manager. So the semantic means like for what we need to create the data system. So this kind of semantics mean. And consistency constraint is the data is maintaining consistency or not. So moving ahead with the entity relationship model. The ER model consists of a collection of basic objects called entities. So there is some kind of employee and manager, basically two entity, employee and manager. And what is employee here? Employee is the one particular entity, and manager is the particular entity. So there is two entity, and manages is the relationship between the employee and the manager. So it just established relation, manages establish the relationship between the employee and the manager. So this sort of it works like this. Now moving ahead with the relation, just mentioned already, relationship model, just it is the collection of table, and we establish some relationship via the we just establish relationship among those entities. So how the database design, we could be a good designer. So the first, we need to requirement analysis. What, why we are creating the database, for what purpose. So we just give the we just check our requirement, why we need, we just check our requirement, then analyze, then execute concept so then later on we think of conceptual design, so that how the user can easily retrieve the data, so that there is some sort of ease to retrieve the information, and ease to give the information to the database also. And some kind of schema refinement is there, so that there is not messed up like a structure in the table. And there is logical database design, make relationship in the form of tables. And there is physical database design, what data structure to use, how the so more very, this is the very much important part of this database design, which is indexing. So indexing, why indexing is important? Within like within a big of constant, within the constant time, we can easily retrieve the information. So the indexing is very much important to the database part. And how the database stored on the drive, like there is a method called b tree, b plus tree. And we also concerned about the security design. So user cannot retrieve the unwanted information, so there is some kind of security requirement also. Let me wait for the ad here, wait for the ad. Security design, then moving ahead with the types of relationship. There is unary relationship, a relationship between the same entity set, like teachers, like educator. There is one educator who is who is supervising other educator too. And there is binary relationship, educator teaches the courses. There is tertiary relationship also. There is some descriptive attribute also, educator teaches courses. So since when this teacher is teaching in the school, particular school. So there is kind of descriptive. Also there is a customer purchase cert, when customer purchase cert. This is kind of description here. Ternary relationship, there is there is three entity involved in the relations, in the relationship. So this is teacher, educator teaches courses in which department. So this is kind of ternary relationship. And there is mapping cardinality. What is mapping cardinality means? Maximum number of relationship instances in the which the entity can participate. The maximum number of maximum number of relationship of instances with the entity can be participated. There is one to one relationship, one to many relationship, many to one relationship. So we have a example like one to many relationship, employee managing teams. So there is one employee can manages the whole team. So there is also many to one relationship. There is credit card to customer. So there is there can be multiple credit card to a one customer. So there is, this is kind of many to one relationship. There can be many to many relationship. So that particular customer can buy multiple product, and this product, particular product, can be bought by multiple customers. So there is kind of many to relationship. And what is participation constraints? There is two type of participation constraints. There is total participation and there is partial participations. What does total participation means? Like it is something like it is dependent, like there is one of the, at most one relationship can be established. So this is kind of department. There can be one manager, there can be one manager to the particular department, where department is dependent on educators. So there is one educator who is managing the department. One kind of there can be particular teacher are HODs of particular department. So HOD, what HOD do, this HOD manages the whole the department system. So there can be a specific educator is given to the particular department. So this kind of participation is there. And what does partial participation means? There can be some of the educator who cannot be managing the whole department system. And there is some weak entity and a strong entity also. Weak entity is like something like this. We can see the example here. A weak entity is an entity that cannot be uniquely identified by the attribute alone, which cannot be uniquely identified because it is dependent on some of the entity. Department cannot be uniquely identified here. So we are seeing the example here. Employee gets family floater health insurance. Like employer purchase some kind of health insurance, and employer stored the data, dependent data, which is not uniquely identified in the DB extended year feature. So we have some specialization, generalization, attribute inheritance, and aggregation. What is a specialization means here? Especially the process of designing, just giving the subgroup to the database design. And the same thing is generalization. This two term is same here. The commonality expressed by the generalization, which can be contained relationship that exist between higher level. So we will not move to the definition, but just see the uh, diagram here. So there is a four-wheeler system, okay? And it four-wheeler is a four-wheeler can be or is a car or a buses. So this is disjoint. An entity belongs to the car. Entities set cannot belongs to the bus entity, and there is overlapping also. Person is a bank employee. Person can buy bank employee and bank customer. Person can be a bank employee can be a bank customer also. So there is kind of overlapping here. Total generalization and the sub generalization. This is not important part in our system. Attribute inheritance, this employee ID. So we will see the system. Employee is a teacher or a developer. So employee is a tester or a developer. So this employee ID and employee name, this developer carries this employee ID and employee name information, because that particular employee can be a developer or is a developer. So these two information are inherited to the developer part. So now moving to the aggregation part. Aggregation is what, the relationship between two entities is treated as a single entity. Like when we develop some system like this, employee works on job. So there is two entity, employee and job, why the relationship works on. And there is also another entity, jobs. So this whole the thing is treated as a single entity. Now moving to the types of attribute. What are types of attribute? There is single valued, multi-valued. So so single valued, we know the further we cannot have multiple information related to the roll number. There is a one particular in particular roll number can be given to the a specific user. So in phone number can have, sorry, single user can have multiple phone numbers. And what is simple and composite attribute? Simple attribute means the further decomposition is not possible here. And in composite attribute, we can divide the info we can, sorry, we can decompose the small attributes like address. We will decompose address into the some sort of attributes like city, state, pin code. So this is the decomposition process in the address system. Also there is some kind of information we can decompose that single data. So what is given attribute and derived attribute? Derived attribute like dob, date of birth, like age can be derived from the date of birth. How this thing, if we mention some date of birth in the database, so we can easily derive the age by calculating. There is a mathematical process behind this. So where, so like think like this, my date of birth is 2004, given in the database. And what is the date now? So we will just minus the minus current date, and my minus dob, date of birth. So there is some kind of we will get the current age, what is the current age of the user. So there is a prime attribute and non-prime attribute. What is prime attribute? We just mentioned about the primary key in the prime attribute, and represented by underline. So this thing we studied. So just ending this session, we have covered week 1 to week 4. Thank you.